Alright, in this video we are ready to begin working on the A-star algorithm. The first piece of A-star that we are going to address is the node-by-node state information that needs to be stored as the algorithm progresses. As A-star is functioning, it needs to remember certain things about the nodes that it has traversed, and since we are in control of the node class, having written it ourselves, the node makes the key and easiest place to store this information. So let's jump over here to the node class and scroll all the way to the top. This state information inside of node is simply going to be represented by a series of fields. So the key purpose of this video is just to get these fields set up. Now, in addition to the fields, we're also going to give a convenient method to reset them, as well as some debug information to draw the state. Once we know the state of each given node, we can draw things about that node that will be useful to us in debugging and following what the algorithm is doing. So let's get things started with our fields. I'm going to jump in here right below the connected list and begin with a comment, just denoting the two different sections here inside of node. This section of fields is going to be for A-star state information. This is opposed to the network that the path nodes represent. So really, once A-star is functioning, the nodes will be performing a dual role. In the first place, they'll be establishing the path node network simply using their connected information. On the other hand, they will also be storing the state information for A-star itself as a path is being solved. Alright, to begin with the fields that we need, the first field we'll need is the parent. So we will make a public field of type node, which is called parent. The next field we'll need is the closed field. So we'll make a public Boolean field for closed. Again, we'll be representing the closed list used with A-star as a simple property node by node rather than a real actual list, since of course the purpose here is to be able to tell whether or not a node is closed. Simply addressing that using a field so that we can mark the node as closed or not closed is the most convenient way to approach this. After this, we're going to add another public Boolean field. Grab some spelling on public. Type is Boolean. This field is going to be called inPath. Now, the interesting thing about this field is, of course, as its name suggests, this will let us mark specific nodes as being part of the final path that got generated after the algorithm was run. Now, as far as the algorithm itself and the path that gets generated, this field is not actually used or rather needed for the inner workings of A-star. This is simply for convenience so that in the debug code we can see what's going on. So in an actual production implementation, you wouldn't need this field. We're just using this to make the visuals easier to draw. So we could even drop down a comment and say that this is purely for visuals. Alright, moving on. The final three fields we need to store are the various scores associated with this node. These are, of course, the G-score, H-score, and F-score. So we'll make some public float fields. First one will be G-score. And since these are relatively similar in name, I'll simply copy and paste twice to make two more duplicates, changing the second duplicate to H-score and the third duplicate to F-score. Alright, this takes care of the fields that we need to store for our algorithm to run. Now, one thing I want to do in addition to these fields is provide a convenient method that will allow us to quickly reset them. Since, of course, this information is getting stored in the node network itself, we need to be able to clear this information in order to do a fresh run of the algorithm. So right after the constructor here in node, we're going to define a reset method. So we will make a method, public void reset, and inside of reset, we're simply going to walk through each of these fields and reset them to a good default value. Beginning with this.parent, we will set the value to null. Moving on to this dot closed, we will set closed to false. Grabbing spelling on false. Moving on from here, we have this dot in path, which will also be set to false. Then finally, the three scores, beginning with this dot gscore. Gscore will get reset to 0. We have two more scores to set. Once again, I will duplicate the score lines so we can set up lines for H score and F score. Alright, with that takes care of all of the state information that is part of Node. Now, one thing I want to do in this video before we bring it to a close is establish our debug drawing information. Since the state information is very simple, looking at it as fields. However, if we were to look at the node network simply from debugging inside of Visual Studio, all we'd be able to look at is the connections in the little pop-up window, and that does not give a very clear visual representation of the network. So what we're going to do at this point is set up a series of draw routines inside of Node's draw method that will let us better visualize each of these fields. Now, the first thing we're going to do is we're going to set up a series of draw layers. Since we're going to be layering different visual information on top of other information, we want to be able to more easily decide when that gets drawn, rather than simply worrying about the draw order. So what we'll do is we'll bring up our style class, which we have open here on the bottom. We'll scroll up in style to just below the color definitions. And here we're going to add a series of layers as simple floating point values. Of course, whenever we're using sprite batch draw calls, we're able to specify the layer depth as the final parameter to any of those calls. Now, rather than hard coding them, we're going to define values here in style to make them easier to read and also easier to manage. So, beginning with the first one, we'll have a public static float field called line layer. And grabbing the spelling, line layer, and we will set this as the very bottom layer. We will set it to a value of 0. Since a lot of this definition is the same for each field, I'm going to copy and paste our line layer field and give it a name of parent layer. This is, of course, the layer that will be used to draw the parenting indicator, and it will be given a value of 0.25. Once again, we will duplicate one of these fields, and we will set a name of actor layer. Actor layer is going to get a value of 0.5. From here, we will move on, duplicate the field again, and set the name to marker layer. And marker layer gets a value of 0.75. Finally, we have our topmost layer, which is going to be our text layer. And the text layer is going to get a layer depth value of 1. So what we've done here is we've named the different layers that we would like to have as drawable layers and provided different depths. And in this case, the logic behind the depths was simply to take the range of 0 to 1, which is the range given by layer depth itself, and breaking it up evenly based on all of our fields. So with these fields in place, we now need to make sure that our drawing code is using these appropriately. Since most of the code that is going to utilize these fields has yet to be written, we'll simply write the code and take it into account as need be. There is one piece of existing code that will need to be adjusted, and that is, of course, the actor class itself, since actors need to be fit somewhere in this layering scheme. Now, to get started, we'll move back over to the node class, move down into the draw method, and we'll begin addressing the various things that we will need to draw. The first of these are lines. Now, of course, we already have some line drawing in place, but we need to enhance this method since when a final path gets generated, we'd like that path to be represented both with markers and lines of a specific color. Of course, lines right now are represented by a rather dark color, so in order to make the path stand out, we'll use a very bright color, and that will make the path much easier to see. Now, as in our line drawing code, we are already looping through all of the nodes connected to the current node, so we will begin working inside of this loop. The first thing we'll do is we will make a line color value, and we will decide whether or not the current lines are part of a path. If they're not part of a path, they'll get drawn with the standard line color. If they are part of a path, then they'll get drawn with the brighter path color. So this variable is going to be a color variable that we will name line color. And then we'll initialize that with a default, assuming that we're just going to use line color. So that is style.line_color. Now we will also drop down a variable to indicate what layer this should be drawn on, since the path layer is going to be brought up to the very top, since we want paths to be prominent, whereas lines themselves can draw in the background behind things like text. So we're going to make a float variable called line layer, and again default this assuming that we're just going to draw these as standard lines. Therefore we will grab the style of line layer. Now we need to do a check and see if we need to move these up in priority and grab the path, color, and layer. So what we'll do is we'll make an if statement, and we'll check a few things about both the current node that is being drawn and the node that we're looking at in the connected list to decide if this line should be considered as part of a path. The first thing we'll do is we'll check the current node, this, and see if it is marked as being in a path. So if this dot in path. In addition to this, we also want to check and see if the current node that we're looking at in the connection is also part of a path. So we will say and node.inPath. Then one final thing we want to check before indicating that this is part of a path is that the node that we're currently looping through is the parent of this node that is being drawn. So we will say and node is equal to this dot parent. This will make sure that we don't end up drawing things that are entirely off the path, or rather if two paths are very close to each other, we don't accidentally draw interconnecting lines. We only draw to the appropriate node that is the parent of the current node. Now if all of these checks come back as true, then we are ready to indicate that this line is part of a path. We'll do this by first taking our line color and setting it to style.pathColor, and taking line layer and setting it to style.markerLayer. In this case, we don't specifically have a layer for paths themselves, since in any case, path is going to be represented generally by a color. We're just bumping the priority of the lines up to the same priority as markers to make sure that the brighter lines don't get overdrawn. Now that we've decided on a color and a layer for the lines, we simply need to adjust the drawLine call to use these variables. So right after fill texture, we have the color that is being fed into the line. Here we will feed in the line color variable. And finally, we have a line layer that is being hard-coded to 0. Instead, we will pass in the line layer variable. All right. With all of these adjustments, our line drawing is now fully functional to be used with debug information. From this point, we can move on to drawing the parenting indicators. So let's begin by dropping down a comment to mark off this section of code and say that we are ready to draw parent indicators. Now, when drawing the parenting indicators, of course, the parent node is going to be very important, so we'll actually copy that reference to a local variable. So we'll make a node variable called parent, and we'll set that to be equal to this.parent. Now we'll do a check before we draw the indicator to first make sure that A, this node is indeed parented, and B, that it's not part of a path. Since in the case of path drawing, we want the lines to be more prominent, so we're going to make sure that they draw instead of parent indicators. So in code, the if statement is going to be constructed of parent, the parent variable being not equal to null, and we want to make sure that we are not currently in a path. So we'll say not this dot in path. If these cases come up as true, we have a parent and we're not in a path, then we need to draw a parenting indicator for the current node. Now to do this, what we want to do is we want to draw the original tail texture that we had loaded in style and orient that texture so that the line drawn by the tail is pointing towards this node's parent. That means we need to get the angle between this node and the parent node. What we'll do here is we'll make a vector to hold this direction, then we'll calculate a rotation from that vector. So here we'll begin with a vector 2. We will call this vector 2 direction, and direction will be set as parent dot position minus this dot position. Now we can turn around and use this vector 2 to calculate a rotation. So we'll make a float variable called rotation, and rotation will be equal to math.atan2, where we can feed in direction.y and direction.x. And of course, atan2 is going to return a double. We'll cast this double to a float before storing it in rotation. Alright, now that we've got the rotation calculated, we're ready to draw the parenting indicator. So we'll use the sprite batch and call upon the draw method. Into draw, we will pass in the tail texture, which is in style.tailTexture. We need to position this using a vector, so we'll be jumping down to the 6th overload of spritebatch.draw. For the position, we'll be drawing the indicator at the position of the node itself. So we'll pass in this dot position. We don't have a source rectangle, so we'll set this parameter to null. Moving on, we have the color that we'd like to draw the parenting indicator with. We can use a color of red. Alright, moving on from the color, we need to pass in the rotation, so we'll pass in the rotation variable. Next we have origin, and now we already calculated the origin back in style so that we would correctly locate the line based on one of its ends, so we'll simply access that origin that is stored in style, which is style.tailOrigin. Next up we have the scale of the sprite. We'll set this to a value of 1. We're not going to use any sprite effects, so we'll pass in spriteEffects.none. Finally, we have layer depth, and we will pass in style.parentLayer. Alright, that takes care of the call to our spritebatch.draw. Let's jump back here to the beginning, and that takes care of drawing our parent indicators. From here, we can move on to drawing markers. Markers are, of course, going to be the colored circles that are drawn around nodes, generally to indicate that the node is in part of the closed list. We'll also maintain the markers when we're drawing a path, and in that case we'll need to change the color of the marker. To indicate this section in code, we'll drop down a comment, and we'll call the comment markers. Alright, we need to construct an if statement to tell whether or not we should draw a marker. Inside of this if statement, we will see if the current node is closed or if the current node is part of a path. So in code, that is this dot closed or this dot in path. So if either of these cases are true, then we need to draw a marker. We'll make a color variable to hold the marker's color, so this can be called marker color, and we'll initialize it to a value of style.closedColor. Now we'll do a check to see if we are part of a path, and if so, change the color over to path color. So we will say if this dot in path, then marker color will be set to style.pathColor. Alright, now that we know the color of the marker, we know that this node should be marked. All I need to do is get the position of the node and draw the marker. So we'll jump into a spritebatch.draw call. The texture we need to pass in is style.markerTexture. We are going to again be using the 6th overload of spritebatch.draw. We need to pass in a position, so we'll pass in this dot position. Again, we're not using a source rectangle, so this parameter is null. The color is going to be given by marker color. The rotation is going to be 0. Our origin is given by the style class as marker origin. Our scale is going to be 1. We are not using sprite effects, so we get a value of spriteEffects.none. And finally, we set a layer depth of style.markerLayer. Alright, this takes care of the sprite batch draw call for markers, and takes care of the markers section itself. Now we have one last section to construct for our debug information, and that is the text section. What we're going to do in this section is draw out the 3 score values, G-score, H-score, and F-score. We're going to draw these values around the node itself. So we'll set F-score to be on the top left, we'll set G-score to be set on the bottom, and H-score to be set also on the bottom. Now we are going to do a check before we begin drawing text. We are only going to draw the score text if the node has a parent. And this is going to be used to reflect the fact that the algorithm has at some point considered the node. This way we avoid drawing a bunch of unnecessary information for nodes that the algorithm doesn't even care about. So we'll begin with an if statement, and we'll check and say if this dot parent is not equal to null, then we do have a parent, which means the algorithm has considered this node. Now when drawing the text, we're going to assign 3 variables to hold various information. The first of these variables is going to be a string called text. Second, we're going to need to know the size of the text as it gets drawn so we can correctly position it around its node. So we're going to make a vector2 variable called text position, or excuse me, text dimensions. I'll shorten this to simply say text dims. Finally, we'll have a vector2 variable called position. Alright, with these 3 variables ready to go, let's begin by drawing the G-score of the current node. We'll start with the text variable, and we will set it using some string formatting. We'll use string.format, passing in a format string of brackets to indicate that we're going to be looking at a specific argument. The argument here is going to be argument 0, and we are going to draw this argument using only whole numbers, no decimal point. So we'll add :0. So if we had wanted to specify a specific precision to be used with the floating point value G-score, we could do that here. Now since we're going to have a lot of information on screen, we're going to keep this down to just whole numbers. So we're going to use the formatting here simply to take the floating point value and chop everything off except the whole integer portion. Now the argument that's going to get passed in is, of course, this dot G-score, and that takes care of the text formatting line. We now have the text ready to go, stored in the text string. The next thing we need to know is what are the dimensions of that string if it were to be drawn. So we'll take our text dims variable, and we will set it using the font's measure string. We're going to be using the small font, so let's grab style.smallFont, or excuse me, font small, and invoke the measure string method that's part of that font. Measure string is going to need the text, so we will pass in our text variable. And again, text dims is a vector2, so we'll simply store that value in text dims. Alright, one last thing we need before we begin drawing is the position to use when drawing this text. So we'll take our position variable, we'll set it to be equal to this dot position. So basically we start with the node's own position. But we're going to add an offset to this to draw the score off to the side. So what we'll do is we will assemble a new vector2 to represent this offset. Our x component is going to be set to negative this.origin.x minus textdims.x. So what's happening here is we want to place this text at the bottom left of the node. So we're using minus origin.x to move us out to the side of the node, and minus textdims.x to make the text work as though it were right aligned rather than left aligned. Now to make sure that the node gets moved in the proper direction in y, we'll set this.origin.y as our offset in y. Of course, positive y moving down the screen means we're going to move the text to the bottom of the node. So with that, we have assembled a vector 2 to use as a position, store that in position, and at this point we are ready to begin drawing. So we will make our call to spritebatch.draw. We will pass in, we'll use drawString. So back up and grab drawString. When drawing the string, we're going to use the font style.font_small. The text is going to be given by the text variable. Our position is given by the position variable, and the color is going to be style.darktext. Finally, we're going to move on to be able to gain access to layer depth. We're going to have to move on to one of the overloads, in this case the third overload of drawString. That means we're required to specify things like rotation. We're not rotating this text, so it will get a rotation of 0. Origin, we're going to leave at vector2.0. Scale is going to be set to a value of 1. Sprite FX will be set to none. And layer depth will be set using style.textLayer. Alright, with all these parameters in place, we can wrap up the call to spritebatch.draw. And looking through here, one last thing I wanted to point out was the color being used here. The most prominent value that we're going to be looking at when watching the algorithm work is going to be the f-score. Now, still having the h-score and the g-score is useful, but we're going to draw them with a darker text just so that they don't stand out as much. That way we can still gain access to the information, but it's not the first thing that catches our eye when we glance at all the information that gets drawn. Alright, with this code in place, we have all the code necessary to draw one of the scores, in this case the g-score. The remaining 2 scores will be drawn in a very similar manner, so I'm going to begin by copying this code, that is the 4 lines going from text to spritebatch.drawString, copying these and pasting them to duplicate them. The next score that we're going to draw is going to be the h-score, so we'll change the text to reflect h-score. Text dimensions will remain the same. We'll simply measure the width of the h-score. Position will change slightly since we're going to draw the h-score on the right side of the node rather than the left side. So we'll draw this using positive this.origin.x, and we won't even worry about text dimensions.x since we'll simply let it draw as though it were left aligned. We will also leave the origin as this.origin.y so that h-score gets drawn at the bottom of the node. Everything in the drawString calls should also remain the same since we're simply using the variables that have been assembled. We're still drawing on the bottom, so we will continue drawing using dark text. Alright, moving on. We have one last score to draw. That is going to be the f-score. So I'm going to make sure that we have these 4 drawing lines copied, paste them to duplicate them, and change the score that gets drawn to the f-score. Now when we're positioning the f-score, we want this to be positioned on the top of the node. As a matter of fact, we're going to place it on the top left. So again, to gain left positioning, we'll take negative this.origin.x minus textdims.x, and our position in y, our offset here, is going to be set using negative this.origin.y, so we move to the top of the node. Alright, most everything inside of draw should be the same. And looking at our drawing here with this.y, let's see, in taking this.y, we probably also need to take the size of the text itself into account, because otherwise we'll draw the text top aligned, which means the text will slightly draw into the node itself. So that means in addition to moving to the top of the node, we also need to subtract textdims.y. Again, this is the counterpart to what we're doing with textdims.x. You need to make sure that the text gets moved entirely out of the node. Alright, with our positioning in place, there's one last thing to change. When we're issuing our call to drawString, we're going to use the color of bright text. Again, since this is the score we're more interested in, since it directly drives what happens in our algorithm, we'll draw this using bright text. Alright, now with all of our text drawing in place, we are almost done with our node drawing. As a matter of fact, let me build and make sure that there's no errors. Everything gets saved out in Node. Now, one last thing we need to address is the actor class itself. Again, we've used a lot of the different layer assignments here in the Node's debug code, but there's one place inside of actor. So if we scroll down and bring up our actor code, scrolling down to the bottom in draw, we're of course still using a layer depth of 0, and we have assigned a specific layer for actors so that the nodes get drawn appropriately with all the debug info. So let's use that here as style.actorLayer. Alright, we have all of our layers set up in all of our various code. Now we need to make sure that that layer gets taken into account by the sprite batch itself. So what we'll do is we'll move over to our scene navigation class, and we'll scroll down to the end. You can see we're using just the standard parameterless call to begin, which means we're going to generally disregard our layer depth. In this case, we need to take it into account, so we need to set the sprite sorting mode. In order to gain access to the sprite sorting mode, if I hit Control K and P to bring up our various available overloads, we can see that if we move down to the third overload, we're allowed access to the sprite sort mode. Now, in addition to this, we also have to specify the blend mode and the save state mode. So let's specify a sprite blend mode of alpha blend. Now we can gain access to sprite sort mode, which we will set to front to back. We're using front to back so that the layer depth can indicate how close it is to the camera, to the screen. That way we can use higher layer depths to indicate that things should draw over other things, rather than using back to front, where we'd have to use an opposite ordering, where 0 would be the highest priority. Finally, we need to specify a save state mode. We'll simply set this to save state.none, since we're not worried about any of the state information. Alright, with all of this put together, we can see that we can build. We're showing no errors, so all of the debug code is ready to go and ready to be used. Now, we do want to make sure we do a brief test to make sure that this code is in fact working, since up to this point we have worked on rather a lot of code here in this debug draw method. And it would be nice to see this in action before we move on, prove that it works before we use it to test the algorithm itself. So what we'll do is we'll move over to our scene editor, where we've set up some nodes to use in testing. What I'm going to do is jump down and space things out a little bit, so we move our node deletions down and are now between building the grid and deleting our nodes. So what we're going to do is we'll begin by testing the parenting indicator. To test that, we're going to need to grab a set of nodes, grab one node, and set its parent to point at another node. So to do this simply on multiple nodes, I'm going to set up a loop that will loop through roughly 20 nodes, maybe 19 so that we can gain a node to begin with. So we're going to construct a for loop. We'll start with our index variable I. We'll loop through the value 20. Now with I itself, I'm going to adjust this so that I actually starts at 1. Then we can use the current node, last node semantics that we were using with things like node connecting. As a matter of fact, to make this easier to see, let's make two node variables. The first one we'll make will be node A, and we'll set this to actor.actors sub I casted as a node. Now we can duplicate this line to put together a variable for node B, and we'll set it to actors sub I minus 1. So that's why we started 1 into the loop, so we will always have a previous node to grab. Now having done this, we have two nodes available to us, so we can set up a parenting relationship. We'll take node A, and we will set its parent to be node B. So with this in place, we have our debug code, all of our drawing ready. Let's build and run the game and see what this looks like. Here we can see that we are drawing these red indicator lines pointing to the parent node. So we can see across each of these we're pointing back to the node's parent as we advance node by node. And you can see on these nodes here on the left edge, see the line pointing up slightly, of course, since it's being parented to this node over here. We can also see that our text lights up the moment we have parent set. So we can see the brighter text for our F score, and then darker text for G and H score. Now, just to see what these look like with actual values, let's set up the scores with some example information. Let's take node A in each case and set its H score to be equal to 50, its G score to be equal to, let's say, 10, and finally its F score to be equal to its, you could say its H score plus its G score. In this case, we'll just hard code these in as 10 plus 50. Again, just giving examples of what these might look like. So you can see with actual values, we're maintaining our positioning. You can also see that the numbers on the left side actually extend out to the left, showing that they are acting as though they were right aligned. Again, this keeps the text from interfering with the node itself. And then, of course, we have our H score over on the right. So, with all of these in place, we can see that the text and the parenting indicators are working well. So let's move on and test the markers. Let's create a second loop below our first loop. We'll make another for loop using index variable I, and again loop up to the value of 20. This time, however, we're going to start I off at 10, so we only loop through a subset of the earlier nodes. Now we want to go through each of these actors as nodes and set their closed value to true. Being closed will then cause markers to begin drawing for these nodes. So we will begin a parenthesis, then we'll take actor.actors sub I, cast it as a node, close the parenthesis, then we can gain access to dot closed and set that value to true. So now we can run, and we can see that closed nodes draw with an orange circle around them. So we can easily see the closed nodes as marked with these circular rings. So this is also working very well. Now we can move on to a final test and see what a path would look like. So let's make a third for loop. This time let's only loop up to the value 17 and begin our index variable at 12. Once again, we need to gain access to the actors as nodes, so I'm going to copy the line where we were testing closed, paste this in, and change the property, or rather the field of interest, to our in-path. We'll set in-path to true through the nodes of a section between 12 and 17. Now if we run, we see we get these set of nodes drawn, one with blue markers instead of orange markers, and we can also see the lines that get drawn between these nodes are also drawing in blue. And again, this makes the path stand out from everything else. So here we can see that all of our debug information is working. We've got lines drawing appropriately both for the background connections and for the paths. We have our parenting indicators pointing at the nodes set as their parent. We have markers set for closed nodes. We have blue markers set for nodes and paths, and we have our paths represented also with lines. So we can see that all of our debug information is indeed working correctly. So with that, now we have tested the debug information. We no longer need this code here, so I'm going to delete it out. And that brings us back to our standard grid with the nodes deleted out of the center. So at this point, we have node state information being stored for the A-star algorithm, and we have debug drawing code to show us that state information. So with this in place, that's going to wrap up this video.